Hi, in this video, we are going to see how to solve a problem on parametric equations. So the question is, find the values of t for where the graph of the parametric equations crosses itself. So we have to find the values of t for which the graph of the given parametric equations crosses itself. Okay, I assume two values for t, that is t is equal to a and b. So these two values, a and b, are different. So that means a and b cannot be equal. Okay, for these two different values of t, I assume the graph of the given parametric equations crosses itself. Okay, so to find the values of a and b, what I need to do is I have to find the Cartesian coordinates corresponding to these two values of t. That is, first I have to find the Cartesian coordinates corresponding to t is equal to a. Okay, to get the Cartesian coordinates corresponding to t is equal to a, I have to plug in t is equal to a into the given parametric equations. When I plug in t is equal to a into the first parametric equation, I'll be getting a cube negative 4a, that is the x coordinate. And now to get the y coordinate, I have to plug in t is equal to a into the second parametric equations, that is a square. So this is a point I'm getting when t is equal to a. The same thing I have to do with the other value of t, that is t is equal to b. Then when t is equal to b, so to get the x coordinate, just plug in t is equal to b into the first parametric equation. Then we'll be getting b cube negative 4b. Then when I plug in t is equal to b into the second parametric equation, I'll be getting b square. Since we have assumed the graph of the parametric equations crosses itself when t is equal to a and t is equal to b, the Cartesian coordinates we get when t is equal to a and the Cartesian coordinates we get when t is equal to b must be same. So because the graph crosses itself when t is equal to a and t is equal to b, the graph of the parametric equation must pass to the same point. So the point we get when t is equal to a, the point we get when t is equal to b must be equal. Okay, so here the 2 points are equal. If 2 points are equal, the x coordinate and x coordinates must be equal, y coordinates must be equal. So we have a cube negative 4a equals to b cube negative 4b. I consider this is equation number 1, and the y coordinates must be equal. So we have a square is equal to b square. I consider this is equation number 2. Okay, I have to solve one of these two equations for a in terms of b or b in terms of a, whichever is possible. Okay, so I prefer the second equation because the first equation we have exponent 3, it may be a little challenging to solve the first equation. So, but in the second equation, I just have the exponent 2. I think I can solve this one easily. So we can solve either for a or b. If you solve for a, you'll be getting the answer in terms of b. If you solve for b, you'll be getting the answer in terms of a. Okay, now I'm going to solve the second equation, that is a square is equal to b square. Okay, to solve for this one, I have to take square root on both sides to get rid of the square root. So the square root cancel. Then here also the square root and square root cancel out. I get a equals to b. Whenever I take square root on both sides in an equation, I have to take positive or negative on one of the sides. Here I am taking positive or negative on the right side. So from this, I get a is equal to b or a is equal to negative b. Okay, this cannot be accepted because our assumption is a and b cannot be equal. But this one says a and b are equal. This cannot be accepted. So we can accept this. That is a is equal to negative b. Okay, now in the next step, what I need to do is I have to plug in a is equal to negative b into the first equation. So when I plug in a is equal to negative b into the first equation, I'll have the complete equation in terms of b. I can solve for the unknown b. Here we have the first equation. I'm going to plug in a is equal to negative b into this equation. So I'm getting negative b whole cube negative 4 times negative b equals to b cube negative 4b. So the simplification of this one is negative b cube, negative times negative become positive 4b equals to b cube negative 4b. Okay, to make 0 on the right side, I subtract b cube and I add 4b to both sides. When I do it, so b cube and negative b cube will cancel, negative 4b, positive 4b will cancel. So I get negative 2b cube, positive 8b equals to 0. Okay, so I can factor negative 2b from these two terms. So if I factor negative 2b out, I'll be getting b square negative 4 equals to 0. So either negative 2b equals to 0 or b square negative 4 equals to 0. So I divide both sides by negative 2. So this negative 2, negative 2 will cancel. I get b is equal to 0. And I'm adding 4 to both sides over here. So I'm getting negative 4 positive will cancel. I get b square is equal to 4. I'm taking square root on both sides. So I get b is equal to positive or negative 2. The square root of 4 is 2. So I'm getting three values for b. B is equal to 0, b is equal to 2, and b is equal to negative 2. Already we know that a is equal to negative b. If I take b is equal to 0, I get a is equal to 0. If I take b is equal to 2, then I get a is equal to negative 2. Because b is equal to 2 means there is a negative sign over here, it will become negative 2. When b is equal to negative 2, so when b is negative 2, this negative times negative will become positive, then we get a is equal to 2. Okay, now we have three values for b and three values for a. Here we have a list of values for a and b we have found. Okay, so please remember that a and b cannot be equal. So if I take a is equal to 0, b can be either 2 or negative 2 because a and b cannot be equal. So if I take a is equal to 0, I have two options for b, 2 or negative 2. If I take a is equal to negative 2, again I have two options for b, that is 0 and positive 2. If I take a is equal to 2, then b can be either 0 or negative 2. In this way, I'm getting 6 different pairs of values. So here 0, 2, the same 0, 2 is repeated here. So we can ignore this. 0, negative 2, the same is repeated here. We can ignore this. Negative 2, 2, the same is repeated here. We can ignore this. So we get three different pairs of values for t because a and b are the two different values of t. So we get t is equal to 0, 2, the first pair. The second pair t is equal to 0, negative 2. The third pair t is equal to negative 2, positive 2. Okay, now what I need to do is I have to check each pair with the given parametric equations. Here we have the given parametric equations. I am going to check the first pair, that is t is equal to 0, 2. So that is first I plug in t is equal to 0 into the given parametric equations. I am getting x is equal to 0 cube negative 4 times 0, which is equal to 0, and y is equal to 0 square, that is also 0. So we get the Cartesian coordinates 0, 0. Okay, now I'm going to plug in t is equal to 2. When I do it so, then I have to plug in t is equal to 2 into the given parametric equations. 2 cube negative 4 times 2, which is equal to 8, negative 8, which results 0. And when I plug in t is equal to 2 into the second parametric equation, y is equal to 2 square, which is equal to 4, then the Cartesian coordinates are 0, 4. Okay, when I take t is equal to 0 and t is equal to 2, I don't get the same Cartesian coordinates. I mean, I don't get the same point. So that means the graph of the given parametric equations does not cross itself when t is equal to 0 and t is equal to 2. So this cannot be the answer because we don't get the same point when I plug in t is equal to 0 and t is equal to 2. Let me check the second pair, that is t is equal to 0, negative 2. So I'm going to plug in t is equal to 0 into the given parametric equations. So I'm getting, already I know that when I plug in t is equal to 0, I get x is equal to 0 and y is equal to 0. So I'm getting the point 0, 0. Okay, now I'm going to plug in t is equal to negative 2 into the given parametric equations. Then I get x is equal to negative 2 whole cube, negative 4 times negative 2, which is negative 8, positive 8, which results 0. When I plug in t is equal to negative 2 into the second parametric equation, I'll be getting y is equal to negative 2 the whole square, which is 4. So the point I'm getting over here is 0, 4. When t is equal to 0 and t is equal to negative 2, I don't get the same point. I'm getting different points. So 0, 0 and 0, 4. So from this, it's very clear the graph does not cross itself when t is equal to 0 and t is equal to negative 2. So this one also cannot be the answer. Let me check the third pair, that is t is equal to negative 2, 2. So now I have to plug in t is equal to negative 2 into the given parametric equations. Already I know the value of x when t is equal to negative 2, that is x is equal to 0 and y is equal to 4. The point is going to be 0, 4. Okay, now I have to plug in t is equal to 2 into the given parametric equations. I'm getting x is equal to 2 cube negative 4 times 2, which is 8 negative 8, we get 0, and y is equal to 2 square, then I get 4. So the point I'm getting is 0, 4. When I plug in t is equal to negative 2 and 2, I'm getting the same point 0, 4, 0, 4. That is, when t is equal to negative 2 and t is equal to 2, the graph is passing through the same point 0, 4, 0, 4. So when t is equal to negative 2 and positive 2, the graph of the given parametric equations crosses itself. So the answer for this question is t is equal to negative 2 and positive 2. I think this video helps you to understand how to solve this kind of problems on parametric equations in AP Calculus BC. Thank you.